Okay, hey, welcome back. This is lesson 1.2. I'm going to cover these 2 pages of notes on exponents and order of operations. So it's not a lot to this. Exponents, you probably already know. We're already familiar with exponents for the most part, but let's kind of define it, know what it is. So an exponent is essentially, it's repeated multiplication. Okay, so that's what's going on there. We got repeated multiplication, and you got the base and the exponent. So here, let's go ahead and just kind of, I don't know, let's just do it this way. We have, like, let's say we have 4 to the 3rd power, something like that. All right, so the base is the 4. This is the big number at the bottom, and the power, the exponent, is the 3. All right, now you probably are aware that does not mean 4 times 3. That means 4 to the 3rd power, or 4 cubed, which essentially is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So that's what 4 to the 3rd power simplifies out to. All right. And so these first couple examples here are just talking about putting it into exponential form. We don't actually have to worry about multiplying it. So right there, we have 5 multiplied repeatedly 4 times. 5 is being multiplied repeatedly 4 times. So the base is going to be 5, and the power is going to be 4. 5 times 5 times 5 times 5. All right, the next one, we've got 4 repeatedly multiplied 6 times. 1, 2, 3, 4, 5, 6. 4 to the 6, and that's it. Okay, so that's, if you look at the way that problem was, or that question was worded, it's worded in such a way where it says find it in exponential form. All we needed to concern ourselves with was writing it as an exponent. For this next one, I already did this one. 4 cubed is 4 times 4 times 4, which is 64. All right. 11 squared is 11 times 11, which equals 121. So we're evaluating these, we're actually working them out. And then for number 5, we're doing 2/3 times 2/3 times 2/3, 4 times over. So just going to work on in the numerator right there. We got 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. So there's our numerator, 16. And then we have 3 times 3, which is 9. And 9 times 3 is 27. And then 27 times 3 is 81. And there's 2/3 to the 4th power. Now notice how that 4, when we're talking about the exponent right there, the 4 is outside of the parentheses, meaning that we're taking that whole thing, 2/3, and we're multiplying it by itself 4 times. So it would be an entirely different problem if it was this. Oops. Like that. If it was 2 to the 4th over 3, that's an entirely different exponent problem, which we didn't have to do. All right, it was 2/3 times 2/3 times 2/3. And then for number 6, we have 1 to the 5th power. All right. These are the easiest ones that are the most commonly confused, I would say, for most people. But for 1 to the 5th power, that just means 1 times 1 times 1 times 1 times 1, which seems like it should be 5, but it's not. It's still 1. It's still 1. So you could have 1 to the 50th power. That's 1 times 1 times 1 times 1 times 1, a lot of times. So that's going to be 1 as well, right? Doesn't matter if it's 1 to the 1,000,000th power. That's also going to be equal to 1, right? So whenever 1 is the base and whatever the exponent is, it's going to be equal to 1. Now, order of operations right here, we've got the typical Pemdas. Please excuse my dear Aunt Sally. You probably have heard that before. Or like one of my other students said, please excuse my drunk Aunt Sally, which I always remembered. That was kind of funny. But yeah, this is the order in which you need to work out a problem. Parentheses, and somewhat the order of operations acronym, the PEMDAS, it's an initialism actually, but that whole thing can be somewhat I don't know, misleading, or it can throw people off sometimes, because parentheses really can be any type of grouping symbol. But what you're going to do is you're going to look for anything that's in grouping symbol. So, it's not just reserved to parentheses. We have parentheses. You might have brackets in a problem. Sometimes we'll help those. You might have, these are called braces, right? Everyone has a hard time drawing them, even me. You have that. Radical sign, square root. That's a type of grouping symbol. You have absolute value. Those two vertical lines that are, like you might have something like that, the absolute value of -9. So any type of grouping symbol that kind of groups up pairs of numbers or groups of numbers is your first order of business that you need to solve, which is to do that first. All right, and once you've taken care of all exponents, you're going to go, or parentheses, you're going to go on to exponents. All right, which we're talking about today. And then right here, I'm going to draw a box around multiplication and division, because in the acronym, please excuse my dear Aunt Sally, all that stuff, multiplication comes before division. However, it's a big capital H, not however. Multiplication does not necessarily come before division. And with this, when it's multiplication and division are together, it's whatever comes first. From left to right. So whatever occurs first, whatever shows up first, from left to right has to be done. Okay, so try not to overthink this. It's not necessarily multiplication and then division. It's whatever happens first. So if you happen to have a problem like this, if you have like 5 times 6 divided by 2, 5 times 6 divided by 2, well, that is, we can just go ahead and do that one left to right, because multiplication just happens to come first in this problem. So 5 times 6 is 30, and 30 divided by 2 is 15. All right, now if the problem was like this, let's say it was like 24 divided by 8 times 10, something like that. All right, division happens to appear first. And so that's the order in which you want to do it. So multiplication, although it appears first in that acronym, it's not what we have to do first. So we're just going to go ahead and do this one left to right. So neither one has more precedence over each other. So you got 24 divided by 8, which is 3. 3 times 10 is 30. Okay. And the same thing goes for addition and subtraction. Same thing. So when addition and subtraction are together, it's whatever comes first from left to right as well. So it doesn't matter. So if you have, if you have a problem like this, like 17 minus 3 plus 4, something like that, if you end up doing the addition first, if you do 3 plus 4 first, it's really not 3 plus 4 if you really think about it, but a lot of people mistake that for 3 plus 4. But if you do 3 plus 4 first and get 7, and do 17 minus, if you do 17 minus 7, that's not going to be the answer. It's going to be 10. That's not the right answer. So we have to go left to right. 17 minus 3 is 14. And then 14 plus 4 is 18. So when they are together, that's the big takeaway that you want to kind of come away from with this, with order of operations especially, is that it's very important that you do those things. When multiplication and division are together, do it from left to right. And same thing goes for addition or subtraction. And also what's important about order of operations is that it's super important. It's not, in this particular lesson, and which I'm sure you've had before, order of operations is not just something that we talk about today and then totally forget about. It's something that is always present in mathematics. You have to keep doing it. It's you have to do it at all levels. It's not just an isolated lesson and you never see it again. We have to do order of operations continually and never forget it. Okay, so going on to the examples right here. These examples look pretty fun, right? So you got right here, we've got multiplication, we've got subtraction, we've got division within parentheses, addition, you have multiplication, and then subtraction again. And the advice that I like to give when it comes to these kind of order of operation problems is like kind of that tortoise and hare proverb or analogy, which is to kind of just follow the principle of like slow and steady wins the race. Just do a little bit at a time, and not try to, some people look at the entire problem and they try to do it all. They're like, okay, 9 times 5 is 45, 45 minus 12, and that ends up being a way of getting it wrong. So what I would suggest doing is just taking it one step at a time. And I like to use, whenever I do a particular step, I like to use those caret symbols, not the carrot that you eat, but caret as in terms of like we're working on an operation. So that's all we're going to do first. And so I recognize that we have to do parentheses first, and then within the parentheses, we have division. So that is what we're going to do first. So we're going to do 9 times 5 minus, and then 12 divided by 4 is 3. And then everything else, you guys will notice here, everything else drops down. Okay, everything else drops down. The 9 dropped down, the 5, all the symbols. The only thing that changed from what the problem was originally to what it is now is that we cleared the parentheses. 12 divided by 4 is 3. Okay. And so now what we're left is we have multiplication, we have subtraction, we have addition in there. So we're going to do multiplication first. Now I see 2 places where multiplication is going on, but let's just go ahead and like I said, let's take one thing at a time. Although you could get away with doing both of those at the same time. I'm just going to go ahead and do that part first. Okay, so 9 times 5 is 45, and then just drop everything else down. Minus 3 plus 8 times 4 minus 32. Okay. And then we're going to go ahead and take care of the subtraction or the multiplication again. Multiplication, 8 times 4 is 32. And so I'm just going to drop everything else down. Nothing else changes. That's all I'm working on is just one thing at a time, just one thing. So we're going to do 45 minus 3 plus, and then 8 times 4 is 32 minus 32. Okay. And then at this point, we can just go left to right because all that's left is subtraction and addition. And subtraction is not more important than addition, nor is addition more important than subtraction. So when they're together, you just go from left to right. That's it. So you're just going to go 45 minus 3. So this, as you can see, the math isn't too difficult. We got 42 plus 32 minus 32. Then 42 plus 32 is going to be 74. 74 minus 32 is going to be, oh, we're back to 42 again. I mean, I know maybe you recognize that there's a 32 minus 32 in there, which is 0, but I don't want to get ahead of myself. So we got 40, we're back to 42 again. That's the answer. That one. All right, so we're done with number 7. But that's when I look at the way that my math students solve these particular problems, the ones that are really careful about every step can typically get those right. They just do. I'm not saying that if you're a mental math genius and you can just do it on your head, you can't. I mean, but if you're new to this, or if math is not the easiest thing to you, just like I said, just take one thing at a time. Just do one step, rewrite the problem, and just do another step. Because when you think about it, the individual math is not that hard, right? The arithmetic that we're doing step by step is not crazy. Like 9 times 5, which is 45. That was not hard. You know, the first thing we did was 12 divided by 4. 12 divided by 4 is 3. So the individual steps, you know, by themselves weren't too tough. All right, so number 8, not a lot going on in this one, other than the fact that we've got to do division before addition or subtraction. So that is what we're going to focus on. So I'm going to do 8 divided by 2, which is 4. And then everything else just drops down. So 11, drop down the -1, plus, but instead of writing 8 divided by 2, write down 4, because that's what it equaled. And then at this point, let's just go left to right. Left to right. So 11 minus 1 is 10. Drop down the +4. And that's easy. That's going to be 14. There you go. All right. So my advice for these, you know, when I assign this on Alex, I tend to give a lot of these. I think practice makes perfect with these. The more you kind of work these out, the better you'll get at them. Because sometimes it can be frustrating, because sometimes we just take the wrong step, or we don't typically do things, you know, in the right order. But I think the more you practice this, the better. So for this particular problem, we're going to take care of parentheses first. And I should note right here, there's a 3 right next to parentheses, which, you know, there's no symbol between the 3 and the parentheses, but we can infer from the way that's written mathematically that that's multiplication. That means 3 times, right? We're going to do 3 times whatever 56 minus 7 or divided by 7 is. 56 divided by 7 is 8. Okay, so that's what I'm going to do. So I'm going to do 3, and then 56 divided by 7 was 8. Oops. Minus 4 squared. Now, if I want to be true to order of operations, I'm going to do exponents next. Although I could get away with doing multiplication, because they're kind of their own thing. They don't really affect each other. But let's kind of be true to the problem here. So 4 squared, that means 4 times 2, right? No, it means 4 times 4. 4 times 4, which is 16. So we got 3 times 8 minus 16. And then we're going to do multiplication next. 3 times 8 is 24 minus 16. And then 24 minus 16 is 8. And just like I said, you know, the steps by themselves aren't too tough. You know, we're not doing crazy difficult math. It's just important that you follow the right steps. That's the important thing. Just make sure you follow every step the right way, and you're good. All right, let's go to this one right here. There's a lot going on in this one. Looks kind of intimidating, but you're going to notice that we have, in this particular problem, we have brackets, okay? And then within the brackets, we have parentheses. Okay, so we have grouping symbols within grouping symbols. And when it comes to that, do the innermost set of grouping symbols first, and then work your way inside out, you know? So we're going to take care of that 28 divided by 2 first. So we're going to take care of that first, 28 divided by 2. And everything else, I'm just going to drop down and kind of keep it written the same way, just so that it doesn't get confusing. So you got 2, and then 30 minus, and then 28 divided by 2 is 14. And I don't need the parentheses anymore because we cleared them out. And then I'll drop down the +5. Okay, make sure when you are rewriting the problem, you're rewriting it also in the same order. Sometimes I've noticed that a common mistake with order of operations is that sometimes people mess with the order. They kind of put the numbers in a different spot from where they were before. You want to kind of maintain the order of the problem the way it was. So we still have a grouping symbol here. Now, they're not parentheses, but they're a grouping symbol, which means we better do it first. So we're going to do 30 minus 14. 30 minus 14 is 16. So you got 2 times 16. I can keep that in brackets if I want, or parentheses, or I can just write 2 times 16. I can do it either way. So 2 times 16 plus 5. Multiplication before division, or before addition, sorry. And so multiplication is going to be 32 plus 5. Then 32 plus 5 is 37. And we're good. Okay. On number 11, for that example here, and you're going to see these from time to time, Now this is written in ratio form, a fraction essentially. And a fraction, it's good to know that a fraction represents division, right? A fraction represents division. Fractions, in their simplest explanation, a fraction means top divided by the bottom. Top divided by the bottom. The numerator divided by the denominator. That's where you're going to divide. However, we've got some problems in the numerator, and we have a problem in the denominator. We want to solve that first. So we want to solve those basically independently. We want to solve them by themselves. They're not kind of, this top part right here. The way we solve that is not going to affect this bottom part. However, we want to solve the top and the bottom and see, perhaps does the top and the bottom divide? Or maybe we can just leave it as a fraction. So that's what we're going to do. We're going to kind of treat these parts as their own little island. And these are not the easiest things to do because the numerator's got a lot going on. We've got a 3, we've got an exponent that's outside the parentheses. All right, meaning we better do that after the parentheses, right? I mean, that's normally how you do it, but that does not mean 2 cubed. That means 5 minus 2 cubed. So we want to figure out what 5 minus 2 is. Again, not too tough. But we're going to do that first. So you got 3 plus, and then 5 minus 2 is 3. So 3 cubed. 3 plus 3 cubed. And then 3 cubed means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. All right, so then that's that part. Now notice I have not touched the denominator yet. I'm just worrying about the numerator as of right now, and then we'll get to that after we're finished with this, which we are pretty much finished. 3 plus 27 is 30, okay? So now let's go ahead and solve the denominator. Let's figure that out. Now the denominator, we're going to do exponents first. Kind of just do it this way. 4 plus 24 divided by 4. And then 24 divided by 4 is 6, because we want to do division before addition. Leave the 4 alone. So we want to do 4 plus 6. And then 4 plus 6 is 10. So there you have it. You have your numerator, which is 30. You have a numerator, which is 30, and we have a denominator, which is 10. All right, and if you treat this like a division problem, this works out perfectly. All right, so you guys can just do 30 divided by 10, which is 3. And that's it. That's all you can do for that one. Okay, on this last one right here, all right, fractions, I guess, just want to throw some fraction in there to keep you honest. All right, we've got addition and multiplication. That's all that's going on. So let's work out the multiplication first. Let's do that first. I'm going to focus in on that. And I'm going to do some cross canceling, which is a good thing to kind of practice every time you see it. But I noticed that 15 and 5 are both divisible by 5. So I can turn that into a 3. 15 divided by 5 is 3. 15 divided by itself is 1. And we can divide 2 and 4 by 2. So 2 divided by itself is 1. And 4 divided by 2 is 2. All right, so now you have 2/3 plus, now what this worked out to, if I look at that, I've got 1 times 3 and 1 times 2, which is 3/2. 3/2, and then plus 1/6. So 1/6. So now it's straightforward addition. And you'll notice we don't have a common denominator here, so we have to find an LCD. Now the LCD of 3 and 2 and 6 is 6, because 6 is a multiple of itself. 6 is a multiple of 2, 2 times 3, and 6 is a multiple of 3, 3 times 2. So what we're going to do is we're going to rewrite it. Now remember, when you rewrite it, the numerators have to change if the denominator changes, right? The numerator has to change proportionally. So we're going to rewrite it with 6 as the denominator. That's what we're going to do. And then we're going to kind of look at the factors here. 3 times 2 is 6, because I'm comparing that to what it was before to what it is now. 3 times 2 is 6, so that's what we're going to multiply on top. So we got 2 times 2, which is 4. All right. Then comparing, going down the line here. 2 times 3. 2 times 3 is 6, so that's what we're going to multiply by 3. So we're going to do 3 times 3. That makes 9. And then 1/6, the denominator didn't change, so you don't have to change the numerator. I'll write it in red to be consistent. And so we got 4/6 plus 9/6 plus 1/6. Well, 4 plus 9 is 13. 13 plus 1 is 14. So you got 14/6. And then that's not in lowest terms. So let's simplify that by dividing it by 2. So if you divide the top by 2 and the bottom by 2, the numerator by 14 divided by 2 and 16 divided by 2, you're going to end up with 7/3. And let's go ahead and just leave that improper. If you want to change it to a mixed number, you can, but I don't see any reason why we don't have to change it. So let's just leave it as 7/3. All right, and I think that does it for this lesson on 1.2. Okay, so I'm going to stop here. I'll pick up I'll do another video for 1.4, because we don't have to do 1.3, even though that's in your notes. That was taken out of the curriculum for this course. Okay, so I'll stop there.